Okay, all right. So the last class we finished off with system logging, so we're going to get right into it. So this topic is going to cover NFS. NFS is network file sharing. So network file sharing is basically being able to share a file, one file on two systems at the same time, or multiple systems at the same time. So you can have three you can have one file that is local on one server, and you can basically export it out to multiple systems for them to be able to mount that file on their system, which will then allow you to place a file or a directory that within that file, which will then appear on all of the systems. All right, just a second. Okay, apologies. All right, you all can still hear me, correct?
Yes.
All right, yeah, sorry about that. Okay,
Yes.
so I was saying network file sharing. So network file sharing is basically being able to share files within between two systems. So it will basically allow you to take a directory and basically place it on another system, and it's both the same directories basically. So touch a file within a directory on one system will basically appear on the other system. So it just allows you to share files between multiple systems. So you can have a file locally on one or directory locally on one system and export it out to multiple systems. All right, so let's get right into it. So NFS is a service. So it's basically a service that needs to be installed on your system in order for you to be able to share these files between the systems. So first, let's check to see, in order to install NFS, it's yum install NFS. Once you hit enter, okay, so it looks like my repository is not configured. All right, so let's go ahead and configure that really quick. All right, so we'll go to settings. Our yum repository is now set up. Let's check, make sure the CD is connected. It's connected there. And we want to mount dev CD-ROM, and we're going to mount that to MNT. All right, so now it's mounted. We do a df-h. See that is mounted there. This was all covered in software management. All right, so I'm going to cd to our etc yum.repos.d, and from there we're going to create a file.repo. Remember, that file has to have the .repo extension. So file.repo. And within this file, the first line will have your name. The next line is your name equals, and then your file name, which is file.repo. Line after that is your base URL. So the base URL is basically the location of where your software is located. So we mounted dev CD-ROM. CD-ROM is where our software is located, and we mounted that to /MNT. So we need to specify /MNT in this location here. So base URL file : / MNT. Base URL. The next line is enabled. Enabled is basically enabling this file. The one indicates that it's enabled. If it was a 0, that means this file is disabled. So we're going to keep that as a 1. And the last line is your GPG check. And we're going to put 0 for that. All right. So let's save that. All right. So now we'll do a yum clean all. And we'll do a yum repo list. All right. So now our repository is now configured. Now we can install NFS. So that's a yum install NFS. All right. So since it's basically telling us that there's no NFS package available, that could be telling us is that we need to specify the NFS package. So we don't know, if you don't know exactly which NFS package to install, you can add the wildcard to your NFS package that you want to install. So once you do that, then it will basically go out and install any package related to NFS. Just a second. All right. So now we'll select the Y as in yes to install NFS. All right, so now it's installing the NFS package. Okay, so now we have NFS now installed. So this system that we installed NFS on, this is going to be our NFS server. So our NFS server is basically going to be the system that is going to have that directory locally. So this system is going to have our directory locally, and it is basically going to distribute that file to any system, and it will then allow those other systems to be able to mount that directory locally on their system. All right. So now NFS is now installed. So the first thing we want to do is we want to basically specify the directory that we want shared to other systems. So let's first see if we have any directories that are mounted. So we don't have any that are mounted as of now. So basically we can now create, we can mount a file system um, that we want basically to be able to share to the other systems. So this is just a regular uh, LVM mount. So let's first check our volume group to see if there's any space. Okay, install LVM2. So it looks like LVM is not installed on this system. So I'm going to go ahead and install it. All right, install LVM2. So that's basically what allows you to create your logical volumes, your volume groups, your physical volumes. There's actually a service that you have to install, but it's not necessarily a service that you have to start. So if I do a VGS, I don't have any volume groups or any disks on my system. So I'm going to go ahead and I'm going to edit my settings, and all these steps that we're currently going through, we should all be caught up and know these current um, these current steps already. Right. So I'm going to add a disk just for 10 gigabytes. Okay. All right. So now we've added the disk, and we do not want to reboot our system. So remember the command, the echo. Close that. We're going to echo these quotes here. And we're going to point that to sys class SCSI host. And we're going to start with host 0, and we're going to scan. Host 0, host 1, and host 2. Now let's do an LSD OK. And now we can see our disk here, SDB, for 10 gigabytes. So we're going to basically mount a file system called data/data. So we're going to go ahead and mount slash data on this system. And that's the file system that we are going to basically share to the other system. So let's go ahead and let's mount that. So first we want to create a volume group. So the VG create. VG data, which is the volume group name, dev SDB. And you see, I didn't create a physical volume first. Once you create a volume group, it will automatically create the physical volume if you haven't done that first. So once I hit enter, so now it tells me physical volume successfully created and the volume group. So it created a physical volume for me as well. So now we have our volume group. So now we can create our logical volume. So we're going to use all of the space, all of the 10 gigabytes of space. So that's LV create. Actually, let's just use 5 gigs. LV create dash L 5 GB dash N followed by the logical volume name. Let's call that data. Actually, let's call that SAP data. Lastly, followed by the volume group name, which is VG data. So now our logical volume SAP data is now created. So now we need to create a file system on top of that volume, that logical volume. So MKFS, and I'm not going to call it XFS, I'm actually going to call it EXT4. Remember, we have different file systems that we can use. XFS, EXT4, EXT3, 2, and 1 for Rails 7. And I believe that Lab 1, this is actually a Red Hat 6 box. So Red Hat 6 does not have XFS. So if I were to create an XFS file system and try to share it out to this system, it could possibly give us some issues. But let's just go ahead and just create ext4, which we know that is compatible with Red Hat 6. So that's mkfs.ext4, followed by the path of where the logical volume is located. So the path is dev vg data sap data. So now we hit enter. So now it's created our file system. So now we want to mount this. So we're going to place our contents inside of FS tab. But first, we can run a BLK ID to get the block ID. You see at the bottom here, dev mapper vg data dash sap data. That's on the ext4 file system. So now we go into FS tab. We go to the bottom of the file, and now we can add the contents needed to mount this file system. So that's dev mapper vg data sap data. So that's our logical volume. That's where our logical volume path is located for in order to place the contents inside of FS tab, which we saw in the BLK, the block ID command. So now we want to specify the directory that we want mounted. So you can call it anything, but I'm just going to call it SAP data. And the file system that we chose was ext4, followed by defaults 0, 0. All right, so I'm going to go ahead and save that. And I'm going to create my directory, SAP data. And now I'm going to mount SAP data. Okay, it looks like I may have misspelled something. Let's go back into FS tab. Okay, yep. The defaults. I spelled that wrong. So it's supposed to be LTS. I put TLS. Now let's save that. And now let's try and mount it once again. All right, so now we didn't get any output. So now let's do a df minus h. And now it looks like we have SAP data is now mounted. All right, so this process that we took just now, we should all be familiar with this process, basically just creating a volume group and creating a logical volume, creating a file system type, and then mounting it. All right, so now we've passed that part. So now it's time for NFS. So in NFS, network file sharing. So network file sharing. All right, so once you install the NFS package like we did, it's going to then allow this path to now appear. It's a file called exports. So in Etsy exports is the main configuration file for NFS. This is the location where we are going to place our SAP data directory in order to be able to send this directory out for other systems in our network to be able to mount on their system. So Etsy exports. So now let's VI into Etsy exports. Etsy exports is going to be an empty file. So there's no content in this file because we need to add the content. So Etsy exports, this file is going to be, the way I'm going to show you is exactly how it's always going to look. So the first section of this file is going to be the name of your directory that you want to export. So what was the name of our directory? It was SAP data. SAP data, right? So SAP data was mounted, so that's slash SAP data. So SAP data is what we want to export. So now we've included SAP data in this file. Now we need to add permissions to SAP data, basically specifying what systems we want to be able to mount this directory, as well as permissions that we will add to this file that the other system will now receive and will then be able to mount. All right, so I'm going to basically input some content here. So the first, and I'm going to then explain it. So star, parentheses, read write, sync, comma, no, underscore, root, underscore, squash, close parentheses. All right. So the first part of our file, of this file, is the directory that we want to basically, that we're specifying that we want exported from this server. So we want to export SAP data. That's the directory we want to make available to other systems. This star right here, this star basically indicates I want all of the systems in my network to be able to mount that directory. So the star indicates every system, any system that's in my network to be able to mount this SAP data directory. But if we don't want any system to mount it, you can specify the IP address of a system that you want to only mount this system. Let's say you don't want, let's say you have 100 systems in your environment, but you only want just that one system to be able to mount. You can indicate star and still be able to mount it on the other system. But let's say the other system's IP address was 192.168.1.58. So this basically indicates that only this system with this IP address can mount SAP data on their system, right? So system, this IP address, this basically indicates that only this IP address can mount SAP data, all right? So let's say you had multiple networks in your environment. You had 192.168.1 dot X, and you had 192.168.2.x. But let's say you only wanted systems on the 192.168.1.x network to be able to mount this directory. So what you will do is basically indicates that any system on 192.168.1.0/24 subnet, so basically any system that is in this range, that is in this IP range, can mount this directory. So any system on the slash 20 192.168.1.0/24, this is basically indicating that any IP addresses between 1 and 255. So 192.168.1.1 through 255. That's basically what this indicates. But let's say you didn't want the systems on the 1.0 subnets. You wanted the systems on the .2 subnets. This is basically where you would indicate that. But in this case, we are just going to indicate the star. The star basically indicates that any system that is in my network can mount this directory. All right. And within these parentheses, okay, yeah, so within these parentheses are basically permissions that you are adding. These are basically default permissions. These permissions that you're seeing 9 times out of 10 are exactly what you are going to use when modifying this file and then trying to export or to make available to other systems. So basically, SAT data is going to have read writes, is going to have read write permissions, is going to be able to sync on any system, as well as no root squash permissions. So these are basically default permissions that are added to the SAP data in order to be able to mount on each of the systems. Ugo, you have a question?
Yeah, I do have a question about that read write permission. Is that what if it's an executable file? Do you put RWX as well or something like that?
Uh, so you cannot necessarily share, or you would not really need to share an executable file. So an executable, or let's say you just wanted to share the content that is in that file, you're not okay. So you won't be able to share an executable file and share it to another system and then run that executable that is being shared on the other system. An executable can only be run locally on your system. So it has to be on your system. So NFS, so this SAP data, the SAP data directory is locally on lab 3 on this system. Once we share it out to another system, it's not actually on that system. It's not locally on the system. It's basically, I'm not sure if you know how file sharing works. It's basically allowing another person to be able to grab it, but is not actually sitting on your system. I'm sharing it to you. I'm sharing it to you, but you don't actually hold that directory. This lab 3 is the master holder of SAP data. SAP data. It's local on SAP data, but it's not like I'm copying it over to the other system. So when it comes to an executable has to live locally on your system. You can't necessarily share it out and then execute execute run an executable on that is being shared on another system. Uh, well, I don't believe so. I haven't had the reason to or to do that, but I don't I don't I don't think I don't believe that you'll that would work. You can actually give that a try, but I've never seen an exports file have read, write, and X. It's only just read and write.
Got it.
Yeah. So just read and write. So read, write, sync, no root squash. So what you're seeing here, the read, write, sync, no root squash, that is default. That's what's always going to be seen in this file. So if you ever get an interview question and they ask you, what's in your export directory, or how do you, once I finish, then I'll explain this in much more detail as far as the kind of interview questions you might see with this. All right, so now we have SAP data. Now this is how our file is going to look. So now we have the star that indicates any system in our network can basically grab this file. And we have the read, write, sync, no root squash. So now we're going to save this file. And now that it's saved, we installed the NFS package. NFS is a service. So we want to start the NFS service. It's a service that needs to be started. So remember, to start a service is, this is a Red Hat 7 system. So it's systemctl start NFS. So now once I hit enter, it didn't give me an output, but let's go ahead and check the status just to make sure it was started. So all right, so we have the green light here, which indicating that it's active. NFS is now running on this system. So now I'm going to add the enable parameter. Enable parameter. Does anyone recall what enable will do to NFS? Okay, yeah, so basically, if I reboot my system, the NFS service will automatically start. That's what the enabled will do. So Red Hat 7 is enabled. Red Hat 6 is check config. Right? So I've added the enable parameter. Clear my screen. So we're still on our NFS server. We haven't hopped over to the other system yet. So now we have the NFS service running. We've updated our etc exports file. That's the main configuration file for NFS. And now what we want to do is we want to basically take that directory and we want to basically place it out into the network for other systems to be able to grab. So in order to do that, the command is export ss space dash AV. Export ss dash AV. All right. So now I hit enter. So now it's telling me, so exporting SAP data. So it's exporting SAP data to any system. So any system now can basically grab SAP data and mount it on their system. So this is our NFS server. So does anyone have any questions so far? Right? So no questions. All right, so now let's hop over to lab 1. So we're currently on lab 3. Now let's hop over to lab 1. So now what we want to do, now on lab 1, so now what we want to do is we want to now mount that NFS export from lab 3 over to this system. So the first thing you want to do is you want to confirm that lab 3 is actually exporting data. So in order to do that, let me grab the IP address of lab 3. IP address 192.168.1.215. So in order to do that, you'll run a command called show mount. Show mount. So show mount dash E followed by the IP address of this system, which is 192.168.1.215. 192.168.1.215. So this is basically telling me I want to know if 192.168.1.215 has any directories that it's exported, right? So once I hit enter, so it's telling me the export list for 192.168.1.215 is SAP data, right? So that's what this system here has exported. So export fs-av, see it's exporting SAP data. This system is on that network, right? So show mounts-e followed by the IP address of lab 3 is basically indicating, hey, lab 3 is exporting this content. So now I can mount this content on lab 1. So in order to do that, you actually go into FS tab, right? So you actually go into FS tab in order to mount that. Okay, so your VI etc FS tab on the other system, on this system. Okay, all right. So the way your line is going to look, so we're going to first start with the IP address of our NFS server, where the data is coming from, where the file directory is coming from. So that was 192.168.1.215. Then followed by the directory that that system is exporting that we want to mount on this system. So that directory that .215 is exporting is SAP data. So in order to add that to this line, you'll add :/SAP data. And the colon is very important. Don't forget that. So 192.168.1.215 followed by the path. So the path is /SAP data. But don't forget that colon. That colon is really important. So now we can, now on the same line after we've placed this content, now you add a space, and now you want to specify how you want it mounted on this system. You can have it mounted as SAP data, or you can have it mounted as data, or you can have it mounted as cars. It's still exporting SAP data, but once it's mounted on Lab 1, you can have it mounted as any directory that you want. So I'll have it mounted as data 1. That's how I want SAP data to be mounted on this system. Okay, does that make sense?
Yes.
Okay,
Yes.
all right, so I want it to be mounted as data 1. All right, so the next parameter that we're going to add is the file system type. So this is not an XFS, this is not an ext4, because we didn't do anything like that. This is an NFS. This is NFS, right? Because we're working with NFS right now. So this is an NFS file system, followed by defaults 0, 0. So basically, we're going to mount SAP data that is coming from 192.168.1.215, and we're going to mount SAP data as data 1. It's going to be mounted as data 1 on this system. As the NFS file system, that's what it's using. Defaults 0, 0. All right, so that's exactly what your line is going to look like. All right, so now let's go ahead and let's save that. And we wanted to mount it as what? Let me make sure I don't have anything mounted. Okay. All right, so we want it mounted as what? Data 1. So mkdir data 1. We need to create data 1, right? Data 1. Okay, it tells me data 1 file already exists. Let me see if there's anything in it. Okay, it looks like we have a bunch of stuff in it. All right, I'm going to remove data 1, move -rf data 1. That was already created on this system already. So now we don't have data 1 and on this system at all. So mkdir data 1. So now we have data 1 created, and now we want to mount data 1. So mounting, we have our contents inside of FS tab. So all we need to do now is a mount dash A. So we did not get any output indicating any errors. So now if we do a df minus h, we'll see here, you see, data 1 is mounted, but it's coming from 192.168.1.215 colon SAP data. So SAP data is mounted as data 1. And data 1 has what? 5 gigs. It has the same amount of gigabytes now as this system. So SAP data has what? 4.8 gigabytes. We exported SAP data over to lab 1. Lab 1 now has mounted SAP data as data 1 with 4.8 gigabytes. So now SAP data is now sharing content, and it can now share content between two systems. So if I cd into data 1 and I touch test 1, test 2, car 1, car 2, red 5, I hit enter, I do an LL, so I have this content here. So that means if I go over to this system and I cd into SAP data, I should have all of that content there. So that's basically NFS. You're sharing contents between two systems. So I can create a directory here, mkdir, and just type a bunch of stuff. And if I go over to this system and I do an LL again, and you'll see I created a directory. It's here as well. So that's basically NFS. You're sharing contents between two systems. Data 1, if I do a df minus h, data 1 is not actually utilizing the storage on lab 1. It's still using the storage on lab 3. It's mounted here, but it's not actually here. But you can still do anything that you need to do as if it was on this system. So I remember, Ugo, you had asked a question about exporting an executable. You wouldn't necessarily need to export an executable. What you can do is, now that you have the file sharing between two systems, like you can change the permissions on like cars 1. Cars 1 is now an executable. And now you have an executable file on both systems. So now you can vi cars 1 from here. Let's say you do like what is it? Which user add has been. So you do has been user add Richard, right? So I did that over here. So if I go over to lab 1 and I do a / on cars 1, user adds no such file directory. Let's see if it created it instead of home directory. Oh, it didn't create it, but you know what you know what I'm referring to basically. I can troubleshoot and see why it didn't do that, but that's basically NFS, sharing files between two systems. So do an LL here. You have your contents. You can create directories here, and it will be placed on another system. So NFS can also be used to copy files, right? You can have a large file that's maybe like 5 terabytes of data on one system, and you can share it over to another system. You can share it, but that other system is not utilizing 5 terabytes of storage. It's getting shared from another system. So now what I can do is I can copy all of the contents now that is being shared over to me. Now I can copy it locally to my system. All right. So any questions?
No questions.
No question.
Okay. All right. Okay, so that's it for NFS. All right, so the next topic is going to be SCP and rsync. So SCP and rsync. So SCP and rsync are fairly similar. It's basically copying files from one server to another. It's basically copying files from one server to another. But the difference is, but they do have differences. SCP basically, let's say, they're both used to copy files. They're both copy files just about the same way. The rate in which, or the speed in which files are copied from one system to another, rsync copies data a little faster, just a little faster than SCP. Um, another difference, another major difference is when you, let's say you're copying a bunch of data, maybe 100 GB of data using SCP, right, from one system to another. You're copying that data, you get to about 40 GB that has been copied over, and then you have a network blimp, a network issue. The network just goes offline, and now that copy has been broken, right? So now you have to restart that copy. So SCP is actually going to override the data that has already been copied and then continue to copy the remaining 60. So it's going to actually recopy. It's going to ask you, hey, this has been copied already. Do you want me to override? And you just select no. And they'll ask me the next one. You just select no and no and no. But I believe there are parameters you can add to your SCP to indicate like yes for all, just to basically like bypass, or no, N for no to bypass. But that's with SCP. But with rsync, let's say you're copying data using rsync, and it's about 100 GB, and you get to about 40 gigs, and the network goes offline, and now you have to restart the rsync again. But with rsync, the good thing about rsync is that once you restart the copy, it's going to automatically detect that, hey, I have already copied 40 gigs already. It's actually going to, and it's going to quickly match and make sure that this is exactly the same as what I have already copied over. And then it's going to continue and copy the remaining 60. So that's the difference, major difference between rsync and SCP. As you can use both to copy, small amounts of data, but it's much better to use rsync when copying data, and not in general, but larger amounts of data is better to use rsync. And another major difference with rsync and SCP, with SCP, once the data has been copied over to the destination, the permissions that were currently on the data, on the files and the directories, they can change once it gets over to the other system. Those permissions at times will change. So the read-write permissions that are on the files or directories can change once they get to the destination. That's just with our SCP. But with rsync, it will actually take exactly what you have and copy it exactly over to the other system. So the permissions, the ownership, all of that will be the same as long as the users and the groups are still on that other system. So that's the good thing also about rsync. It actually checks and makes sure that the permissions and the ownerships of the file and directories and the permissions on the executables are going to be exactly the same once those files and the directories reach their destination. All right. Any questions so far? All right. Okay. All right. So let's actually test this out. So what I'm going to do, let me look for a section on the system where I know has a lot of data. So I know var log has a lot of data here, right? And these are all log files. It has a whole bunch of logs here. So basically what I'm going to do is I'm going to copy the entire log directory right here using SCP as well as rsync. Okay. All right. So I'm going to copy that from this system, 192.168.1.204, and I'm going to copy it over to lab 3, which is 192.168.1.215. Right. Okay. One last thing, really quick about NFS that I forgot to mention. The reason why we were able to mount that directory over with no issue and be able to see those files between two systems, because there was actually no firewall running. That's one thing that's also important as well. If you have a firewall running on both systems, what we have to do, you have to open NFS ports. You have to open the NFS ports on both systems in order to be able to mount that share and create those directories. So NFS does have ports. I believe it's about I believe it's actually about 8 ports, 8 NFS ports. That's if you have a firewall running. Yeah, you don't need to know those ports by heart. You'll never get asked that in an interview. But NFS does have ports. Those, and if you have a firewall running, that's something you can even test out. If you have a firewall running, you can open those ports and test that out and mounting. Okay. All right. So I'm going to SCP that log directory from this system over to this system, which is 192.168.1.215. All right. Okay. So we're currently inside of the var directory. All right. So to SCP, so the first thing you do is SCP. So SCP followed by what you want to send. So what do we want to send? We want to send, we're currently inside the var directory, so we want to send the log directory that is currently inside of this var directory. So if we weren't inside of this var directory, let's say we were inside of the temp directory, but we wanted to send the log content. So it'll be SCP var log. So what do we want to send? We want to send the log directory. But the log directory is inside of var. So you need to specify the path of what directory or file you want to SCP. All right. So we want to send the log directory. So SCP, the log directory, followed by the destination. So SCP, what you want to SCP, followed by where you want to SCP it to. So we want to SCP it to that 192.168.1.215. But we need to specify a user on that other system that we want to be able to receive this content. So we can't just put 192.168 1.2.15, right? We need to specify the user on this system, but we're doing this as root, right? So we're going to specify that, hey, we want the user root on that other system to be able to receive these files, this directory that we're sending. So we're going to specify root at this system. So SCP, what do we want to SCP? We want to SCP the log directory. And we want to SCP the log directory to where? To the user root that is at this system, 192.168.1.215. So we're going to SCP the log directory. The root the root user is going to receive this content, the root user that is on this system. All right. So we're not just going to toss it anywhere on that system. We have to specify where on this .215 system we want to place that log directory. So in order to specify where, you have to add colon followed by the path on this destination system where you want it to be placed. So we're just going to place it inside of /temp. So we're just going to place it inside of /temp. All right, so I'm going to hit enter. So now it's telling me basically, are you sure? If you see at the bottom, it says, are you sure you want to continue to connect? Basically, are you sure you want to initiate copying the data? Right, so I'm going to put yes. Once I hit yes, it's going to then ask me for the password, for the root password of this system, the root password. So we specified root that's going to receive this content, right? But let's say there was a user called T Smith, right? We said T Smith, we wanted T Smith to receive that content, but then we would then specify the password for T Smith. But we're just using the root user, right? So we all know that the root user password is ABC123. All right, so once I hit enter, this is most likely going to fail. So this is failing. It's telling me the directory that we're trying to send is not a regular file. So so the log directory is not a file, it's a directory. All right. So when you are sending directories, right? We're sending var log. The log is a directory. When you're sending a log, you need to add the -r. The -r basically means recursive. We want to send this we want to send this, we want to send it recursively because it's a directory. Whenever you send a directory to another system, you have to add the -r. If it was only a file, it will not tell you, it will not give you this error. You have to add the -r. So SCP-R followed by what we want to send, which is var log. We want to send the log directory that's located inside of var. And then where do we want to send it to? We want to send it to this system, 192.168.1.215. And the root user on that system is going to receive this log directory. And the destination on this system we want to send it to is /tmp/temp. So now I'm going to hit enter once again. Now it's going to ask me for my password again, ABC123. Hit enter. All right. So now you'll see that it has sent over all of my data. Seeing 100%, 100%, 100% for all of the data that is inside of the log directory. So it's basically sent it over to the other system inside of the temp directory. So if we hop over to lab 3 and we cd to the temp directory and we do an ll, we will see right here, log. Log was sent at 21:06. Do a date. What time is it? It's 21:07 now, right? So that log directory was just sent on March 5th at 21:07, 21:06. All right. So if I cd into the log directory that's here, and I do an ll, I'm not sharing. This is not NFS. This is actually just copying, right? I could have shared the log directory using NFS, but this is copying. I SCP, I copy. SCP stands for secure copy, right? Secure copy protocol. That's what SCP stands for. It's basically um, yeah, just copying data, but it's doing it securely, basically. Secure copy protocol. So if I cd into my log directory, I do an ll, and now I have all of the logs, the contents that was inside of var log, right? Ugo, you got a question?
Yes. The Will this also, like, how you were saying for NFS, if there's firewall up, then you have to open specific firewall ports, NFS ports, I'm sorry, to allow this the file sharing. Is that the same thing for the protocol copy, the
Okay,
secure
so
copy protocol?
yes, so secure copy uses port 22. So if you're able to SSH over, if you can SSH to 192.168.1.215, you can SSH like I'm able to. If you're able to SSH, then you can SCP.
I see.
SCP uses SSH ports 22, and so does rsync. But NFS does not use port 22. NFS uses, I can Google that really quick. NFS uses few ports. Okay, yeah, so NFS uses, or the main ports are 2049 and I believe 111. I believe it's more than that though. It's a few. Mm, yeah, it's a few. All right. All right. Okay. All right. So that's basically SCP. So secure copy protocol using that's SCP, basically copying contents from one system to another location. Remember, if you get this is not a regular file, when you're trying to send the data, it means that you need to specify the dash R, specify the dash R, the cursive. Cursive allows you to send directories. All right, so any other questions with SCP?
No, sir.
Hey, Adewale.
I just noticed that the it uses the same port as SSH.
SCP.
Yes.
Yes, yep, yeah. SCP uses the same port as SSH. Yep, port
Oh, okay.
22.
Yeah, okay. That's
Yep,
I just want to confirm that when you said 22. Okay.
yep, yeah. So if you're able to SSH over to the other system, then you'll be able to SCP.
Oh, okay.
So SSH, yep, yep. So port that 22 for SCP and SSH use the same ports, and also rsync uses the same port as SSH and SCP. So
They're
all
all
of
okay.
those, yeah,
I'll use
use
port
port
22.
22. Yeah, they all use port 22.
Thank you.
No problem. All right. Okay. All right. So now I am going to go back to lab 3 here. I'm going to go cd dot dot, and I'm going to remove the log directory. All right. The log directory is now gone. So now I'm going to send the same log directory using rsync. All right. I want to send the same log directory using rsync. All right. So in order to rsync contents from one system to another, you use rsync. So rsync. So rsync There are so many different ways you can send data from one system to another using rsync. But the most general way to do it is rsync followed by these flags here, which is dash A, V, and Z. A for append, V for verbose, and Z. Don't recall what Z is. Let's do a man rsync. All right, so let's scroll down and look for these. Um, a lot of information. Okay, so the first one dash V. V for verbose. A dash A for archive. That was append. And the Z. Let's look for the dash Z. See, there's so many different ways you can send data across. Okay, so dash Z is compress. Compress file data during the transfer. So that is looks like it's actually shrinking it during the transfer. So while it's transferring, it's actually compressing it, which is allowing it to send faster, to send that content quicker. All right. So if we had a whole lot of data, like maybe like a terabyte or 100 gigs, and we were sending it, you'll be able to see the difference in the speed. Rsync is much faster, but they both send data the same way, but remember the differences that I explained to you. All right, so it's rsync dash avz, and the way and after this, the other commands are basically the same as the SCP. So basically it's rsync dash avz, just like this. So rsync dash avz, and what do we want to send? We want to send the log directory, and we want to send it over to this system 192.168.1.215 as the root. The root user will be receiving it, and we're going to place it inside of slash temp. So it's being kind of sent the same way. They're sending the same way, but it's sending using a different command, using a different way. So when you're sending, rsync is mainly used for sending large amount of data because you want the permissions to stay the same. But if you're sending maybe 5, 10 gigs, you can still use rsync. You can actually use rsync as a permanent way to send data. You can use it as a permanent way to send data. No one is going to stop you and tell you, hey, why are you using rsync? Rsync is mainly used to send large amount of data because we want it to be quicker. Um, it when it sends the data over, the permissions are much more aligned than SCP. SCP at times, the permissions and the ownerships of the files will become adjusted. Yeah, but with rsync, it sends the data much more quickly. And one of the major differences that I explained is if you're sending a terabyte of data from one system to another, that can take some time. And you can have an interruption in the network that can break the copy. But with rsync, exactly where it broke is exactly where it's going to start when you restart the rsync. But with SCP, it's not going to start from where it broke. It's going to scan the entire. It's basically going to start from the top and say overwrite, 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 and then continue from where it left over. All right. So now we have rsync-avz. We're sending log, which is inside of var. We're sending it over to that system inside of the temp directory. All right, so it's going to ask me for the password of the destination system as root, so it's ABC123. All right, so now it's sent over. So it kind of sent over a little differently. Once it was completed, it told me of um, the amount of bytes that was sent, and also the speed in which it's sent. So I believe this is, not sure what this is measured in, and it tells me the total. Uh, basically provides detail on how it's sent. But like I said, there are so many different ways you can send data using rsync. You can send it. You can there are like some pause parameters that you can add to rsync that like while you're sending it, it will, you know, take a break at times, or you can actually you can actually do an rsync which will now provide you the speed in which it took each file to send. So that can also be used for troubleshooting. Like, hey, this is taking too long to send the data. I need you guys to make adjustments to the system so that the transfer wait can be much faster. So that's how to send data using rsync. So any questions with rsync and SCP?
No question.
No, sir.
All right. All right. So the last topic we're going to cover today, this is going to be the last one, is web services. So this is web services. So what we're going to do is we're basically going to build an Apache server, and we're going to basically configure an HTML file, which would then allow us to display content in our HTML file on the internet. So we're actually not actually publishing content to the actual internet. What we're doing is we're doing this locally from your home network. Only you'll be able to see it. Like, it's not like you can tell your friend, hey, I just put something online, you should go take a look. This is just being done locally in your own home network. And you will then be able to, play around with this and configure it to just to how you want it, and play around with it. So this is basically configuring Apache. So you're not necessarily as a sysadmin going to make adjustments to like Apache code, unless that's a route that you want to take as far as being a like a developer or so. But you definitely need to know how to install Apache and where the configuration files are located, and um, and how the HTML where the HTML code is located in case you need to make any adjustments. There usually you'll have a developer that will basically direct you to where in the HTML code you'll need to make adjustments to. All right. So we're going to do this on our Red Hat 7 system. All right. Okay. So the first thing that we're going to do is we're going to install HTTPD. And HTTPD is basically yum install HTTPD. HTTPD is basically the main package for Apache. This is the main configuration package for Apache. So yum install HTTPD. Right. So does anyone remember the difference between yum and RPM? All right, we'll go.
Um, I believe Yum will resolve all dependencies for your installation of your packages, and RPM, you actually have to go and find those dependencies.
Yep, that's correct. Yeah, so that's a common question you'll be asked. But yeah, yeah, that's a common question that'll be asked. So when you get simple questions like that, you got to make sure you answer them like quickly, quickly, precisely, straight to the point. All right. So now we've installed HTTPD. So now once HTTPD is now installed, you will now be able to cd into a directory called var dub html. So the dub html, www html, that those directories now become available because you installed HTTPD. You don't create those manually. Once you install HTTPD, those two directories become available. So var dub html. Second. Okay. All right. So now those two directories become available. All right. So var dub html. This path, var dub html, this path is also known as your document root. So this path is also known as your document root. So if you ever get asked, like, what is your document root? You tell them it's var dub html, right? So if somebody tells you, you need to go to your document root to make this adjustment, they're referring to var dub html. So this path is your document root. Google, you had a question?
Yes. You mean document root as in like root user, or document route as in like bus route?
Um, Documents route. No, not root user. No, it has nothing. No, doesn't have anything to do with the user. Or is it document routes? Maybe I'm just pronouncing it wrong. Document. Yeah, document root. Yep, ROOT. Yeah, document root. But the root is not indicating the root user. It is just called just document root. I believe document root is actually just one word. So it's not like document space root, it's document root. So that's just the path. This path just means document root.
Got it.
Var dub HTML. Yeah. All right. So this path here is where your main Apache configuration file is going to be located. So it's empty now because we don't have anything configured here, right? So it's a dot HTML file. So any dot HTML files that you see here are basically being hosted on a website. You can have your company's website can possibly be in this path. Your company's website can possibly be in this path, depending on what they have set up. So they can have a file that is called it has to be a .html file. So it can be called like index.html. So I'm going to create a file that is called index.html. All right. So this file is basically the main HTML configuration file that is configured in depth. It is a lot of HTML code that is used to host a website. That is basically used to host a website. So I'm not sure if any of you guys have seen HTML code, um, but it's you can Google HTML code. So I'm gonna vi this index.html file, and I'm going to, just place some HTML content in here. And this content that I'm placing in here, I don't know how to write an HTML code. I'm just showing you an example of what you're going to see once you get into the work field. So the first line is going to be HTML, like this, and the second line is going to be your header, and then followed by, let's say, like a title, and put this is a title. So any HTML code that you find online, you can place it here. But once we're done, I'll show you basically how to see this content that you've placed here on your internet browser. So the next line will be your body, and the next line will basically indicate what you want to see on your internet browser once you web to it. After that is your body, and we'll end that with HTML. All right. So I'm not going to explain what is being done exactly here, but what we're going to do is we're basically going to take this content, hello world, and we're going to now be able to see it on our browser. So if we actually published our IP address with a publishing company like GoDaddy or so, or a publishing company, you can then take that IP address, place it on the internet, and you'll see hello world, right? So you want to save that file. So that's our index.html file. That's our main Apache configuration file. That's our main Apache configuration file, the .html. So the package that we installed was HTTPD. HTTPD is also a service, and it needs to be started. So we need to start that service. So systemctl start HTTPD. And we're also going to give it the enable parameter, just like that. So now let's check the status of HTTPD to make sure that it's actually started. All right, so it looks like we have the green light there. All right. So now I'm going to pull up my browser here. Can you all see this?
Yep.
All right. So let me see. What is my IP address of this system? So 192.168.1.215. So 192.168.1.215 index.html. So index.html. All right, so I hit enter, and now we see hello world. So this is basically what this index.html file is your main Apache configuration file that is configured using HTML code in order to be able to host your company's website. And that's basically what Apache is basically doing. When you hear Apache, that's HTTPD. Right, so any questions? So there's so many different types of code. If you wanted to play around with this, you can place some code in here and make sure you make sure you if your firewall is running, if your firewall was running, do you guys know what port you'll need to open for Apache or for HTTPD?
Is it port 53?
Port 53 is DNS. So port 53 is DNS, port 22 is SSH, port Apache is port 80. So those are like um those are basically like the three major ports that you need to know. Um yeah, those are basically like the three major ports that you need to know that could be asked in an interview. Yeah, those are the major three that you need to know and that could be asked during an interview. Uh, all right, so I know we covered a pretty good amount today in a short amount of time. We're moving pretty quickly. We actually have three more topics remaining until we start um, interview prep. So I believe next class we should be able to, if it's not next class, two more classes, we should be able to wrap those three remaining topics up. But that's basically it for NFS, SCP, rsync, as well as web services using HTTPD for Apache.